Hello friends, I'm Mohnish and welcome to a new video of Codex-Mohnish. So today we are going to study depth sensors, but today we are going to look at the CV2 BGR2GRAY. So we are going to see a CV2 function here more specifically today. So now let's get started with our code. So this is all the story which we are doing from the past few videos. Okay, so we'll just so this is like for spawning the camera. So this function like should be called to spawn a camera. So it will find a camera and it will be a RGB camera with the image size of like with 640 pixels, 480 pixels as height, and FOV as 70. So into this function creates a camera sensor. And second, we have the actor list. So here, the actor list will contain all the actors which we are spawning in the Carla environment. So here we are just spawning two actors, which is the car and the sensor. So first we are trying to connect to the Carla, then we are trying to get the client connection, then we are getting the blueprint, and then we are trying to get a random vehicle to get spawned here. So what do you like? So random vehicle here is like, so this random is a module here. So in that choice the function and get blueprint of the world is a variable which has the blueprint library. And from that we are filtering vehicle and the star dot star means anything. So actually in Kala the vehicles are stored like vehicle is a class, like it's a group or it's a list of vehicles, like all the vehicles in Kala. So in that vehicle you have a subset. In that you have a subset. So I'll just show you the how vehicles are stored, like vehicle names in Kala actors. So okay, actor live spawning. Okay, wait. So you see vehicle dot. Okay, so this code is already there. I think like I think this is the actually the same thing which I used here. Like so here like the Kala stores the vehicle names as like vehicle, then it will store one like main subset. In that you have like the main car. So like I have a file like which I'm not able to find now. So I'll be showing that file in the next video probably, and we'll just get to the next nine. This is spawn point. So random dot choice, we'll get the map and we get the spawn points, like spawn points, and we are going to get a random. We are just going to choose a random location and we are dropping the vehicle in the spawn point like, and we are giving the vehicle like that thing, and we are setting the autopilot as true, and we are just calling the simulator camera rotation location. So if you like, I'll not explain this thing now, like, but if you have not understood what is it, then you can go to my previous video which I just uploaded yesterday, and you can watch that. And so here we are calling the camera sensor. So here the camera function, so we defined it here. So you remember we defined it here. So I'll just see. Okay, now. Okay, so camera sensor. We are setting the spawn point for the camera sensor of location like 2.5x and Z as 0.7. Like so, it will be 2.5x front and 0.7 like up. And then we are going to spawn it like the camera sensor at this location, and we are going to attach it to the drop vehicle. So as the drop vehicle moves, the camera sensor will be moving. And then we are calling a lambda function which will get the camera data, and the image function will get like, so lambda function, like we use the lambda keyword. So if we give a argument here, so which the camera data which we are getting from the listen function, and from that we are going to take the image. Like image is the defined function which we have just written, so we'll just go through that, and in that we are sending the parameter camera data. And so we are appending these two actors and we are sleeping like for 1,000 seconds. So it will work for 1,000 seconds. The code, like then it will kill itself. Like kill here doesn't mean this kill cool and all that. So here killing the program is like stopping the program from execution. Like so now destroying actors, like it for actor in actor list. So actor list contains all the spawned actors. So it will destroy all the actors as we kill the program. So now let's go to the image definition here, like the function. So image takes a positional argument image here. So this matrix representation, okay, np.array, okay, raw data. So raw data is again a variable or attribute of the image class. So image is a class here, which we are getting from the sensor.listen. From that, we are having an attribute raw data. So we are getting that, and we are making an array from NumPy using it. So NP is NumPy here. I It's a alias name. I imported NumPy as like MP, and then reshape of the image. We are reshaping the thing, and then we are reshaping the live feed, and then we are setting a final feed. So your final feed is CV2 dot convert color. CVT color is convert color. So this is like what you want to convert, and this is like this thing is in BGR. So in CV2, all the images are first stored in BGR, blue, green, red instead of RGB. So even though when you are trying to represent something like uh here like we are getting the image data from the Carla, so that's not a problem. But when you work with CV2 libraries using Jupyter Notebook and all that, so I have few notebooks in which I use CV2. So like you need to frequently convert the BGR into RGB for the results. But so similarly, like so we are converting it to gray here, so grayscale, and we are showing a final feed, not the live feed. And then we are waiting for one second and returning. So now after this, we'll be checking for the depth sensors as well. So I'll just run this code, and now I'll just run Carla. I'll I use low quality settings like so it doesn't lags my PC. And now I'll just cd my like cd is like change directory, and Python API cd. Uh, okay, this is project code, and then Python is the keyword. Okay, so I'm in Carla environment. Okay, so Python project 212.py. So this is the name of my file. Okay, so you see the BGR is converting my uh RGB view like which we are already having to gray, like BGR view to gray. So here I think the car is moving. So like I just kept the camera view so we don't need to go with the car. Like it's quite disturbing sometimes. Like so this camera view will help us here. So it stopped here. But okay, now let's have a look at the depth sensor. So we had a look at the depth sensor in the last, I think second last video, like 2 days ago we uploaded that video, so you can check that. So now we'll just, instead of just seeing what depth sensor are, we'll just change this thing to depth. And as we are changing it to gray, so we'll get, instead of the green black lines, we'll get the gray and black lines. So we'll just run this code. I'll just CLS this thing and I'll just run the code again. So we'll get that feed again. So I don't need to open Gala, and my computer CPU fans are like running like ooh, and you see the depth sensors like they're trying to visualize the environment. So you see the depth sensors. Okay, I think the car is stopped somewhere. Like okay, so car is oh, okay, okay. So I don't think I opened it in the low quality settings. I think I did some type error, like typo. So why did the car stop? Okay, it was traffic signal, red light, red light, green light. It will move. See, Carla has its own thing, and you see the car, it was random. So last time I think we got a different. Okay, I did not show you the thing. So I'll just stop it and I'll just run the code once again. So you'll see the random car here. Okay, if the car comes same this time, like it's not a problem. Okay, so you see, I think it's a Nissan car. Wait, no, it's a Audi car. Okay, so it's by the way, it's a Audi car. So this is the a spawn point. Like this is the default spawn point, like which is zero. I think like no, this one. So this spawn point is 0 and 1, and you have this Carla thing at the center, and I think it's spawned there. So that's 13 spawn point maybe. So that's it for today, friends. Thank you for watching the video, and please don't forget to subscribe the channel, and you'll be getting more informative videos. Thank you, friends. Bye bye.